Hello students, welcome to the chapter Inverse Trigonometric Functions. This is lecture number 6. In this video, let us solve some problems on the principal values and also some properties of inverse trigonometric functions. Question number 1. Find the value of sine inverse 1 by 2 plus cos inverse minus 1 by 2. Dear students, let us consider the given expression as it is. Sine inverse 1 by 2 plus cos inverse minus 1 by 2. To solve this one, sine inverse 1 by 2 value is pi by 6, as you know, plus cos inverse minus 1 by 2. Need to use a property cos inverse of minus x, that is pi minus cos inverse x. So here x value is 1 by 2. Then pi by 6 as it is plus pi minus cos inverse 1 by 2 value is pi by 3. So now solving this expression, taking LCM, that is 6, and multiplying to the numerators, so that pi plus 6 pi minus 2 pi. So if you solve that pi plus 6 pi minus 2 pi, we are going to get 5 pi in the numerator divided by 6. Dear students, this is a question for 1 mark. So very simple question using properties and standard values of trigonometry. Question number 2. Find the value of sine of pi by 3 minus sine inverse minus 1 by 2. Take the expression sine of pi by 3 minus sine inverse 1 by 2. Here also I am going to use some properties, simple properties, pi by 3 as it is, plus because sine inverse of minus 1 by 2 is, as you remember, sine inverse of minus x property can be minus sine inverse x. So here we have sine inverse of minus 1 by 2. This can be written minus sine inverse 1 by 2. So if I write minus sine inverse 1 by 2 here, so this minus and this minus will be together, plus we are getting. So that's why I am writing plus directly. Next, sine inverse 1 by 2 as it is. So the value of sine inverse 1 by 2 is pi by 6. I will replace sine inverse 1 by 2 pi by 6 in the next step. So sine of pi by 3 plus pi by 6. Dear students, sine pi by 3 plus pi by 6 simplification now. Sine of taking the LCM and multiplying to the numerators. So 2 pi plus pi upon 6, that will be sine of 3 pi by 6. 3 ones are 3 twos are. So sine of pi by 2. So sine of pi by 2 value is 1. So this is the required solution for the question number 2. Question number 3. Find the value of sine of pi by 2 minus sine inverse minus root 3 divided by 2. So this is a question that we have to solve. Let us consider the expression once again. Sine of pi by 2 minus sine inverse root 3 by 2 minus root 3 by 2. So here also I am going to use the same property of sine inverse negative, that is sine inverse of minus x is equal to minus sine inverse x property I will use for this expression, so that you are going to have the next step easily, that is sine of pi by 2 plus it will be, so sine inverse root 3 by 2. Remember the value of sine inverse root 3 by 2, that is pi by 3. So sine pi by 2 plus pi by 3. So solving pi by 2 plus pi by 3 in the next step, that will be sine of 5 pi by 6, taking LCM multiplying to the numerators. So sine of 5 pi by 6 value can be written in a simplest way. Sine of 5 pi by 6 I will solve here. Some of the students will be remembering directly, or else you can take it. Pi minus pi by 6. So sine of 180 minus theta will be sine theta. So that will be sine pi by 6. So sine pi by 6 value is 1 by 2. Remember directly, or you can simplify like this also. That is sine of 5 pi by 6 is 1 by 2. So this I am going to show you now. That is sine of 5 pi by 6 is 1 by 2. This is the solution for question number 3. Now let us have some properties of inverse trigonometric functions. In the earlier session also we discussed properties of inverse trigonometric function. Here also we have some more properties. Let us see those. This property is going to help us in converting the inverse trigonometric function from one to the other. Conversion of one inverse trigonometric function to other, that will be done by the properties that we are going to see now. Number 1, sine inverse of 1 by x can be converted into cosec inverse x, where x belongs to the domain of cosec inverse. Then cos inverse of 1 by x can be written sec inverse x, again x belongs to the domain of sec inverse. Tan inverse of 1 by x is equal to cot inverse x, then x belongs to the domain of cot inverse, but here tan inverse of 1 by x equal to cot inverse x, where x is greater than 0. These three property will convert one inverse trigonometric into another. Sine inverse to cosec inverse, cos inverse to sec inverse, tan inverse to cot inverse. The proof of these will have now. First one, sine inverse of 1 by x equal to cosec inverse x, where x lies between these values. Proof of this, let me take sine inverse 1 by x as theta. So apply sine on both the side, so that left side sine of sine inverse, so 1 by x remains, right side sine theta after applying sine on both sides. Now x, taking the reciprocal, x is equal to 1 by sine theta in the RHS, that will be cosec theta. So apply cosec inverse on both the side, so that left side cosec inverse x and right side cosec inverse of cosec theta. So cosec inverse x equal to, from the property of inverse trigonometry, cosec inverse and cosec removed, only theta remains. Replace the value of theta here, that is cosec inverse x equal to sine inverse 1 by x, because you have taken theta as sine inverse 1 by x. This is one method, apply sine on both sides, apply cosec inverse on both sides, or else you can take in this way also. Same method number 2, same pattern but little changes I will do here to understand better. Sine inverse of 1 by x equal to theta, taking sine inverse to the right side to understand, that will be sine theta. Then now taking reciprocal on both the side, hope you remember how to take the reciprocals. Taking reciprocal, so that 1 by x reciprocal will be x, sine theta reciprocal will be 1 upon sine theta. So from trigonometry, 1 upon sine theta can be written cosec theta. Then cosec you take to the left side, so that cosec inverse x. So when cosec went to the left side, only theta remains. So now you can replace the value of theta from above. Theta is sine inverse 1 by x. So theta will be sine inverse 1 by x. So this is also a kind of proof. If you want the method number 1, that you can apply, or if you followed method number 2, that you can apply. No problem in the examination. You will get marks. 2 marks you will get. Hope you understood. Like this we are going to prove all the properties related to this. Second property, cos inverse of 1 by x equal to sec inverse x, where x lies between the required values. Proof, let me take the LHS, that is cos inverse 1 by x equal to theta. Apply cos on both the sides, so that cos of cos inverse removed 1 by x, in the right side cos theta, because you are applying cos. So reciprocal, x equal to 1 by cos theta, but sec theta right directly. Apply sec inverse on both sides, we get sec inverse x equal to sec inverse of sec theta after applying sec inverse on both the side to the above step. So in the right hand side, sec inverse sec will get removed, so that sec inverse x is equal to just theta. Then sec inverse x is equal to theta you replace, that is cos inverse of 1 by x. Hence proved. If you not followed this one, better you prefer this method, that is cos inverse of 1 by x is equal to theta. What actually I have to do, like previous, cos inverse right side. So 1 by x is equal to cos theta. Then taking reciprocal on both the side, as I proved in the previous, so that 1 by x reciprocal is x, cos theta reciprocal is 1 upon cos theta. From trigonometry, 1 upon cos theta is sec theta. Then taking sec to the left side, sec inverse x is equal to theta, and finally you replace theta value from above, that is here, that is cos inverse of 1 by x. Hence we proved the property. I am giving the two methods for the property. Which one you prefer, that you can follow in the examination. Number 3, tan inverse of 1 by x is equal to cot inverse x, where x is greater than 0. Proof of this theorem, let me take the LHS. Tan inverse 1 by x equal to theta. Apply tan on both the sides. So left side only 1 by x remains, right side tan theta. Taking reciprocal, x is equal to reciprocal of tan theta will be cot theta. Apply cot inverse on both sides, so that cot inverse x equal to cot inverse of cot theta. In the right hand side, cot inverse cot get removed, only theta in the RHS. Therefore, cot inverse x is equal to theta. Replace the value of theta, that is cot inverse x is equal to tan inverse of 1 by x. Hence proved. If you follow this method, follow it. Otherwise, you can prefer the previous method that I have discussed separately to this question also, to this property also. You will get the answer easily. We'll move to the next property. This property will help us in evaluating the inverse trigonometric functions easily. To evaluate inverse trigonometric functions easily, let us use these properties. One very important property, sin inverse x plus cos inverse x is pi by 2. X belongs to the domain of sin inverse and cos inverse, that is minus 1 comma 1. Second property, sec inverse x plus cosec inverse x equal to pi by 2, where x belongs to the domain of sec inverse and cosec inverse. Third one, tan inverse plus cot inverse x is equal to pi by 2, where x is belonging to the set of real numbers, that is the domain of tan inverse, cot inverse. Dear students, these three are the most important properties in this chapter. Please remember these three properties. These definitely help us to solve the problems easily. So let us have the proof of these three. Sin inverse x plus cos inverse x equal to pi by 2. X belongs to the domain. Proof of this one. Let me take sin inverse x as theta, because theta lies between the range of sin inverse, that is minus pi by 2 to plus pi by 2. Apply sin on both the side. So x equal to sin theta. Then sin theta can be converted into cos, like cos of pi by 2 minus theta. Then apply cos inverse on both the side. So left hand side cos inverse x, right hand side cos inverse of cos pi by 2 minus theta. In the right hand side, cos inverse and cos get removed. So cos inverse x is equal to just pi by 2 minus theta. Now cos inverse x is equal to pi by 2 minus, I am replacing theta value. Theta value is here, that is sin inverse x. So after replacing that, we are going to get sin inverse x, and taking sin inverse x to the left side, so that plus sin inverse x plus cos inverse x is equal to pi by 2. Hence we proved this theorem. Sin inverse x plus cos inverse x equal to pi by 2. Let me take it one more time. What we are doing here, anyone, either sin inverse or cos inverse, take it as theta. So taking sin inverse to the right side, so x is equal to sin theta. Students, you must convert sin into cos, because one more inverse trigonometric function, cos inverse, is there. So write sin theta as cos of pi by 2 minus theta. Now take cos left side easily, cos inverse x, then pi by 2 minus theta. Replace theta value from above. Theta you can see, that is sin inverse x. Let me take sin inverse to the left side. So sin inverse x plus cos inverse x is equal to pi by 2. Hence we got the theorem sin inverse x plus cos inverse x equal to pi by 2. Either you follow this method or this method. I am giving both the methods. Both are similar, but little changes I am doing. Instead of taking apply cos on both sides, apply sin on both sides, I am writing directly. We will move into the next one. Second one, sec inverse x plus cosec inverse x equal to pi by 2. X belongs to the domain of sec inverse and cosec inverse. Let me take sec inverse x as theta. Theta lies in this because of the range of sec inverse x. Apply sec on both sides, method number 1. So x is equal to sec theta. Now you need to write sec theta in terms of cosec, pi by 2 minus theta. Then apply cosec inverse on both the sides. So cosec inverse x equal to cosec inverse of cosec pi by 2 minus theta. In the right hand side, what happens? Cosec inverse and cosec get removed, so that cosec inverse x is equal to pi by 2 minus theta. Now you will replace theta. Now you can take theta to the left side, so plus theta. So theta plus cosec inverse x equal to pi by 2. Replace the value of theta, that is sec inverse x. Theta you can observe sec inverse x. Sec inverse x plus cosec inverse x is equal to pi by 2. Hope you followed this property. Otherwise you can follow the previous that I have discussed in the property 1 of sin inverse x plus cos inverse x equal to pi by 2. Like that also you can solve here. Hence we proved this theorem. Let us see the next third one. Tan inverse x plus cot inverse x equal to pi by 2, where x belongs to the set of real numbers. Let tan inverse x equal to theta, as theta lies between this one. Actually it is just less than the range of tan inverse is open interval minus pi by 2 comma plus pi by 2. So just less than pi by 2, greater than minus pi by 2. Next, apply tan on both the side. X is equal to tan theta, then x equal to tan you write in terms of cot pi by 2 minus theta. Apply cot inverse on both the side, so that cot inverse x is equal to cot inverse of cot pi by 2 minus theta. So in the right hand side, cot inverse and cot get removed, then cot inverse x is equal to just pi by 2 minus theta. Cot inverse x is equal to pi by 2 minus, replacing theta, that is tan inverse x. So taking tan inverse x to the left side, so tan inverse x plus cot inverse x is equal to pi by 2. Hence we proved tan inverse x plus cot inverse x is pi by 2. Dear students, please remember all these three properties. One is sin inverse x plus cos inverse x is equal to pi by 2. Second one, sec inverse x plus cosec inverse x is equal to, directly you write pi by 2. And the third one, tan inverse x plus cot inverse x is equal to pi by 2. For all these three, remember x belongs to the domains of respective inverse trigonometric functions. Why we have to study these three properties? Suppose an example of sin inverse 1 by 2 plus cos inverse 1 by 2. Instead of simplifying the principal value of sin inverse 1 by 2 and cos inverse 1 by 2, directly apply sin inverse x plus cos inverse x is pi by 2. So directly here x is 1 by 2, even x is also 1 by 2. So directly you can write the answer pi by 2. Instead of simplifying with principal value, you can use these three properties. Hope you understood all these properties. Remember, so that it will help you to solve the inverse trigonometric functions problems. Thank you students. We will meet in the next session with some more questions or properties of inverse trigonometric functions. Thank you.